Today we will discuss about the payment processing service, a Spring Boot project. Now the introduction to the project. So overview is introduction to the payment processing service. So what is the objective of today's coding? The objective is to ensure that the data provided by the validation service. So here if you are observing in a diagram, this is the entire flow of our graph. So first the e-commerce client, it will send the request. That request it will come to the validation service, and the validation service, after validating the request, it will send or delegate the request to the processing service, and the processing through the processing service, if everything is okay, then it will store in the database. Then after that processing service, that request it will delegate to the Stripe provider service, and the Stripe provider service for a further payment processing, it will interact with the Stripe PSP provider. So this is the entire flow. Here when the client send the request to the payment processing service, then the after validate it will go through the processing service, then delegate the request to the Stripe provider service, and the Stripe provider service it will interact with the payment processing service to process the payment, and then the same response is sent back to the Stripe provider, that response, and through the Stripe provider to the processing, and the processing to the validation, and validation to the e-commerce client. So what is today's objective? The today's objective is when the clients send the request, it receive the validation service. After validating with the payment processing service, we are all the data whatever it is received is stored in the database. So the objective is here is to ensure that the data provided by the validation service is accurately and efficiently stored into the database. So for here we are using the Spring JDBC name the template in order to work with the database. This involves implementing a robust mechanism to handle the received data, performing the necessary data transformation. So we are using the data transformation, the mappings, and using the database operations to insert or update the records in the database schema. So this is the objective of today's work. Now, so the project purpose, why we are doing this project, a Spring Boot application. This is a Spring Boot application to handle the different payment methods, providers, and payment types and transaction statuses. So in our project, we are using the various configurations, so controllers, services, DOs, entities, POJO classes, factory class. We are implementing the factory method. Spring JDBC template we are using. Now then the project structure. The project structure, so we are designing a layered application. That layered application we are packaging the various layers. So in that we are having a main application class, controller class, the DTO and entity, POJO classes, enums we are using, configuration class, DO implementation, payment status factory, service implementation, handlers for a transaction status, various transaction statuses we are discussing on today's objective. So now we will go through the work project. So we will discuss about. So here is the payment processing service. So here if you are observing, we are using a layered turn in order to configure all the classes. So this is the layered application. So here if you are observing, we are using the various packages. So com.cpt.payments is the base package. In that base package, so all these packages, if you are observing that config package, constants, in a config we are using the app config, constants, various constants we are using, the constant package, enum package, enum, so we are defining in a constant, controller layer, this is called as a controller layer, service layer, so this is the service interface, service layer. So these are the various packages we are using. This is our project structure. So here if you are observing, see, this is the com.cpt.payments is the base package. The payment processing service application. See, payment process, our application payment processing service application. This is the starting point of our application. It sets up the necessary configuration and start the application. Whenever the any application, it will start with the main method. So here if you are observing here, @configuration will configure the application, @spring boot application, @enable async, and @enable scheduling. These annotations bring in order to the application. Now the next layer, we will start with the controller layer. So whenever client send the request, that request it will be received by the dispatcher servlet. The dispatcher servlet then it we get the request to the payment. So whenever the client send the request, first it will come to the main method, then after execution it will come to the controller layer. So that's why first we will start our coding the controller layer. So here if you are observing, here we are using the annotation @REST controller. So @REST controller annotation indicates that this class is a Spring MVC controller, Spring MVC model view controller, where every method returns a JSON or a XML response body rather than rendering a view. It makes the class a RESTful web service controller. So @request mapping, @request mapping, this annotation maps the HTTP request. So the HTTP request to a specific handler methods, in the controller. The base URL. See, if you are observing, this is the base URL @request mapping. And annotating, this is the /v1/payment is the base URL. The base URL for all requests handled by this controller /v1/payments. Now here we are using a dependency injection. The constructor of the payment controller. See, the constructor of the payment controller class accepts the two dependencies. So here we are using a constructor dependency. We may use on top of this @AutoAdd on payment service uh, on payment service check, and or we may use the payment controller class accept the two service. So here if you are observing model mapper, this is used for converting the objects. See, this model mapper we are injecting here also payment service. We will discuss in detail what is meant by a model mapper and the payment status service. This is the service layer. Here we are injecting the two objects. This is used for converting. The model mapper is used for converting the object from one type to the another, specifically from transaction. Here we are transaction to transaction DTO in this case. And the payment service. The payment service, this is the service interface likely implemented that handles the business logic. So the service layer which will handle the business logic in processing the payment statuses. So these dependencies, the model mapper and the payment status service, these two dependencies are injected into the controller by a spring when it creates an instant payment controller. Now the next, here if you are observing @post mapping, @post mapping, this annotation maps the HTTP post request to the create payment method. So here we are in this class, in this payment controller class, we are injecting the two dependency injections. After that we are writing the payment, the create payment. This method will trigger when a post request is made either. So here we are writing a value equal to blank and a slash. So we may write our URL as a /v1 slash payments or /v1 slash payments slash. So we may use the two URLs by using this value. Now create payment method. By using the create payment method, this method handles the payment creation process. Let's go through the step-by-step coding. So here in this create payment, we are using the @request body annotation. @request and is in the object transaction object. We are passing as a parameter. So this annotation, this @request body annotation, this annotation binds the incoming JSON of the post request to the transaction object. The transaction object represents, this transaction object represents the data received from the client. Whatever the data sent by the client, that it is represented by this transaction object. So where here we are writing in a POJO. So here transaction is layer. See, this is the transaction class. Here whatever the data which is received from the client, we are in a transaction object. So this log is a statement are used for the debugging and logging the flow of the method. For that we are in this logging. Then next, here if you are observing, the model mapper is used. So here the model mapper is used to convert the incoming transaction. The incoming transaction object which is sent by the client into a transaction DTO object. The transaction DTO will likely have the same similar fields, but it is used for the service layer due to a different needs of validation and processing. So here the transaction object is converted into a transaction and it will give the transaction DTO object. Now the payment processing. The transaction DTO is passed to process the status method of the payment status service. This method processes the payment. This method processes the payment and returns a transaction DTO. Here, transaction DTO with updated information like the status of the transaction. A new create transaction. A new create transaction response object. A new create transaction response object is created to form the response, and this object is populated with ID and transaction ID from the returned transaction DTO. So here if you are observing, the new response This object is populated with the ID and transaction status ID from the return transaction DTO. Now returning the response. A response entity. See here, a response entity is created to encapsulate the response body. So whatever the response, it will encapsulate in a response entity, and the HTTP status. See the HTTP status code, HTTP status created, which corresponding to 201 status, then it is returned as a HTTP response. So in this controller method handles a post request. See, this controller method handles a post request to create a payment by a create payment method. It receives a transaction object. See, it receives the transaction object in the request body. In a request body, converts it into a transaction DTO. Converts it into a transaction DTO using the model mapper. Process it using the payment status service, and then returns. See, using the payment service. See, here we are writing the payment status service, and then returns a response with a transaction ID and the results on the transaction and status. The method logs the various steps. See, we are writing the various logs of the process to help the debugging and tracking the flow of the data. So this is about the controller class. Now then next we are discuss about the DTO and entity classes we are writing in our code. So DTO and transaction DTO. So here if you are observing, we are in a com.cpt.payments.dto. Here we are writing the transaction DTO. This is a simple object used to transfer a data between a different parts of the application. It includes a various fields. See, it will include a various fields. ID, user ID, payment method, provider, payment type ID, transaction status ID, amount, currency, merchant transaction reference, and transaction reference. These are the various fields using. It includes the various fields and represent the transaction details. Now then, the transaction entity. This represents a database entity. It has the same field as DTO. See, it has the same field as DTO, but uses the integers. See here, if you are observing in a DTO, all these parameters, string, the payment provider ID, payment type ID, transaction data, it is in a string. While using in an entity, we are using as the int. See, this represents the database entity. It has the same field as a DTO, but uses the integers for a fields that corresponding to enums. Those are corresponding to the enums. So here we are writing the enums. See, the payment method, payment type, provider, and the transaction, taking it easier to store into the database. That's why we are using the int in order to store into the database. Now, in our project, we are using the various enums. So, those are defined under the com.cpd.payments.constant package. So, here in this project, we are using payment method enum, payment type enum, provider enum, and transaction status enum. So, what is the use of these enum? Why we are using? These are the special classes. All these enums are the special classes that define a set of constants. For example, if we take the payment method enum, this payment method enum defines a different payment methods. The payment method here we are using the APM. So enum ensure that only a valid values are used throughout the application. That is the use of the enums. Now then, we will discuss about the configuration class. So this app configuration we are writing under the package com.cpt.payments.config. So we will go through this entire coding. We will discuss, we will understand how the model mapper is working. So app config, this is the class used to configure the application. It includes the model mapper bean, which helps in converting a data from one type to another, such as DTO to an entity or an entity to DTO. We are able to convert by using the model mapper. It is the custom converter. Make sure that the string values are correctly mapped to their respective enum type. So here we will discuss in detail. We are writing on top of this app config class @configuration. So what is the use of this configuration? Configuration annotation indicates that this class contains the one or more string beans, which are methods annotated with @bin. So here @bin that returns an object managed by the Spring container. So @bin annotation on the model mapper method tells Spring that this method returns a bin that should be registered in the application context. In this case, it returns a model mapper instance. See here, model mapper is equal to new model mapper. It will return the model mapper instance. Now the model mapper is a library that simplifies the process of mapping one object to the another, often used to map the between data transfer objects and entities. Now here if you are observing, we are using the custom converters. These custom converters are used to convert the one type to another during the mapping process. In this code, we are using the four converters. Payment method converter, payment type converter, and provider converter, and transaction status converter. So this payment method converter, here if you are observing a string from the DTO to an, it will convert the string value from the DTO to an integer using payment method enum dot get by name context dot get source dot get id. So this converts essentially map a string of values from DTO, like the name of a payment, to their corresponding enum values, and then get the integer ID associated with those enum values. So here if you go to the payment method enum, here see public static payment method enum get by name string name, and the public static payment methods enum get by id in id. So in this app config, if you observe this code, so here this converter, it will convert the string to an integer by using the payment method converter. In this payment method this converts essentially a map string values from the DTO and to their corresponding enum values, and then get the integer ID associated with this enum. So based on context dot get source dot get ID. Now then next we will discuss the create type map. So the create type map method is used to create the custom mapping between two types. In this case, the transaction DTO is the source and transaction entity is the destination. Here, if you are observing, mapper dot using payment method converter. This applies the payment method converter when mapping the payment method field from transaction detail to transaction entity. Similarly, for other fields, the other fields payment type, payment provider, transaction status, ID are mapped using their respective converters. So the return type is the model mapper. Finally, the configured model mapper instance is returned and registered as a Spring Bean. This bean can now used anywhere. This bean can be used anywhere in an application to map between the transaction DTO and transaction entity. Map between this transaction DTO and transaction entity when the custom converters are applied. Now, what is the use of this model mapper? This configuration setups a model mapper bean with a custom converters to map the specific fields from the DTO to an entity, ensuring that string fields in the DTO are converted to integer IDs. See, these string fields are converting into the DTO to a integer IDs in the entity based on corresponding enum values. So this is the app configuration class. Now next we will discuss about the now implementation. So here in com.dd.payments.dao.impl. So this transaction DOIMPL, this class interacts with the database. This class will interact with the database. The create transaction. See here if you are observing the create transaction method inserts a new transaction record into the database and return the created transaction details. The transaction DOIMPL class is a data access object. This transaction IMPL class is a data access object implementation that handles the interaction with the database for a transaction entities. This class is responsible for saving the transaction to the database. Now then we will discuss in detail. So as we know the @component annotation marks this as a this class is means it is marked as it is managed by a Spring, and meaning it will automatically detected and registered in the Spring context. This allows the other component to inject and use this TAO implementation. Now here the dependency injection we are using AutoWire. So model mapper injecting with the @AutoWire. Similarly, we are injecting here a named parameter JDBC template. So this model mapper is used to map the between the DTO and transaction entity as we discussed in app field. And the named, see here we are using the named parameter JDBC template. This is a Spring utility that simplifies working with the JDBC and SQL, allowing us to execute the SQL queries using the named parameters. Now, then the create transaction. This create transaction method is responsible for inserting the new transaction record into the database. So here we are writing the logs for debugging process. the next we are writing here. Here the model mapper. See here, if you are observing, here the model mapper is used to map, is used to convert the, see, it is used to convert the transaction DTO, the data transfer object, into a transaction entity that matches the database structure. So why we are using the mapping? So the transaction entity, why we are using it, matches with the database structure. That's why we are in a transaction entity. This is necessary because the transaction entity represents how the data will be stored into the database. Now then next we will construct the SQL query. So this SQL string, if you are observing, we are writing the SQL query, it will stored in a string SQL. This string SQL is an insert statement, insert into a transaction. This is a transaction table name that specifies the fields to be inserted into the transaction table. The placeholders, if you are using user ID, for example, represents the name parameter that will provided in the next step. Now executing the query. See here, if you are observing a bin property SQL parameter source. So this bin property SQL parameter source is used to map the properties of transaction entity, the entity object, to the named parameter in the SQL query. So what is the purpose of this bin property SQL parameter source? Is used to map this transaction, map the properties of this transaction entity, the entity object, to the named parameters in a SQL query. This means that the user ID field in a transaction entity will be automatically mapped to the user ID placeholder in the SQL query. So this is the use of new bin property, and all those are stored in the named parameter, the SQL parameter source. So this next, the key holder. So what is the use of this key holder? The key holder is used, this key holder is used to automatically generate the primary keys. So in this case, the ID is the primary key after the insertion operation. Now then execute the query. See here, for executing the query, here. For executing the query, the update method executes the insert SQL statement. It takes the SQL string, the named parameters, the key holder to capture the generated key, and an array specifying which column to capture. In this case, the ID column. And it will be stored in an insert row count object. Now after inserting operation, after successfully inserting the operation, the generated primary key. So whatever the generated primary key, here it is the transaction ID is the primary key. It retrieved from the, see, it is retrieved from the key holder and set back into the transaction DTO object. Here it will set back into the transaction DTO object. So after, means again I will after insert operation, the generated primary key, that transaction ID, see that transaction ID, based we are getting key holder dot get key dot value, then it will stored in a this transaction ID, and then this transaction ID is retrieved from the key holder and it again set back into the transaction object. Now this This method logs the number of rows inserted and the generated transaction ID, then returns the updated transaction DTO. We log all this, which now indicates the new ID. So here we will return the transaction DTO. So what is the use of this transaction DO IMPL class? Is a DO implementation that handles the inserting a transaction, that will handle the inserting into a transaction into the database. It uses the model mapper. It will uses the model mapper to convert the transaction DTO into transaction entity and construct a SQL insert statement, execute it using the named parameter JDBC template, captures the generated transaction ID and update the transaction DTO with ID before returning it. This method is essential for persisting a new transaction into the database. So this is the overall about the transaction DO IMPL, how to store the data to the database. Now then next we will discuss about the factory method, the payment status factory. So we will discuss about the controller layer, then we will discuss about the what is the use of the model mapper. We will discuss in the app config what is the use of enum that we discussed, the DAO layer, transaction DTO entity. Then we will go through the payment status factory. What is the use of this factory method? Now, the payment status factory class is a factory that provides the appropriate status handler. Appropriate status handler implementation based on the transaction status. It uses Spring application context. So, if here we are injecting the Spring application context to dynamically retrieve beans for the specific handles. Let's break down the code. We will discuss in detail. See, as we know, component annotation on top of this payment status factory. It marks this class as a Spring managed bin. Means it will automatically detected and it will store into the Spring context. Now the dependency injection, we are using @AutoWired on top of this application context. So the application context is a Spring container that holds all the bits and can be used retrieve them at the runtime. By auto-wiring it, factory can dynamically obtain bits based on the transaction status. Now here in this class that payment status factory, this get status handler method. This method takes a transaction status enum as an argument. So this is a transaction status enum as an argument and it returns a corresponding payment status handler. So this get status handler, it will accept as a transaction status enum as a parameter and it will return the payment status handler. The method uses in this method it uses a switch statement to determine which handler to return the based on the status enum. Based on the status enum, it will return the right. Now here next if you are observing created. So the case 1 is created. If the status is created, the factory prints a message. A factory prints a message indicating that it's creating a handler for this created status. Then retrieves the created status handler. Then it will retrieve. See, based on this context, see, application context, based on this dot get bin. Then it will retrieve the created status handler of bean from the application context using this context.getBean created status handler. This handler return to the caller. So it will return to the caller. Now the next, here the case is initiated. Now as of now it is null. If the status is initiated, the factory currently returns a null. This could be a placeholder where you might want to add another handler in the future. So if the status does not match, if the status does not match with the created or initiated, the specified cases, the factory logs that is unable to find the handler. So this is about the method. So the next, here we are writing payment status handler, get status handler. It will accept the status ID. The method for convert the status ID to the corresponding transaction status enum, and if then it delegates to the logic to the get status handler transaction status enum method. So the overall this means the payment status factory class is a factory pattern implementation that provides the appropriate payment status handler based on the transaction status. It uses the Spring application context. See, it uses the Spring application context to retrieve the correct handler bean in a runtime. So this factory this factory allows the application to be flexible and easily extensible. So easily extendable means as you can as of now we are using only two status created and initiated. In future we may add a few more statuses in this class. Now then next we will discuss about the service implementation, service layer we will. So controller layer we discuss various DTOs, entities, enums, app config. Then we will go through the service layer. We discuss the factory pattern. Now this payment status service IMPL is the class contains the all business logic, whatever the business logic we are writing in a service layer. So this class contains the business logic for processing a transaction status. The process status, see here the process status method. This process status method determines the appropriate handler for the transaction status and process it. The payment status service IMPL class is the implementation of the payment status service. See the payment status service in interfaces we are writing the payment status service here we are writing the processor status. It handles the processing the transaction statuses by using the payment status factory to determine the correct payment status for given transaction status. Now as we discussed the at the rate component, so here we are injecting the payment status factory check. Now this process status method is the core functionality of this service. It processes the status of a transaction by delegating to the appropriate handler. Now this log, so this log, whatever we are writing, logs the incoming transaction DTOs for the debugging purpose. Now in the next, if you are observing this transaction dot transaction status enum dot get by name transaction dot get tsn status id. This transaction dot get transaction status id method retrieves the id from the transaction. Then this transaction status enum Dot get by name method converts this ID into a corresponding status enum. This enum represents the status in a more structured and a safe manner. And this will log the transaction status enum for debugging purpose. We are writing the log. Then next, the status factory. See here, the status factory dot get status handler. Uh, there are status enum method is called to retrieve the appropriate payment status handler for the given status. This handler will contain the specific logic to process the transaction for the status. So here status factory dot get status handler, and this status handler, based on this status handler, then process the status and pass the transaction and whatever the response. See here, this status handler dot process status method is called to process the transaction using the specific logic implemented in the handler, and this result is stored into the response status process status response. The process it will return the process status response to the caller method. The process transaction DTO, then it is returned as a result of the process status method. Here the transaction DTO is a return type. Now the means this payment status service IMPL class is responsible for processing the status of a transaction by delegating to the appropriate payment status handler based on this transaction status. It uses the see here it is uses the payment status factory to dynamically determine which handler should be used. Now then in our class we are using the various handlers. So these classes, so we will discuss the in this com dot cpd dot payment service dot impl handler. We are return a created status handler, field status handler, failed status handler, initiated status, pending and success. So these classes handle a specific transaction. So these are the classes are used to handle the specific transaction statuses. For example, we will discuss about the failed status handler. So this is the failed status handler. Process that have failed, each handler updates and update the database accordingly. So here in this handler we are writing the created status handler, failed status handler, initiated status handler, pending status handler and the success status handler. So this is the entire code in order to whatever we are in our objective. So this is the payment processing service. It is thoroughly designed with a strong emphasis on the best practices in a software engineering. So this architecture demonstrates a clear separation across a different layer. So we are using a different layers such as a controller layer, service layer, data access objects, ensuring that each component focuses on a specific aspect of the overall functionality. This approach, whatever we are writing, is easy to maintain. Also, it easy to test. So overall this architecture is a flexible and a robust payment processing service that can easily adapt to future requirements without necessitating the extensive code changes. Now then we will run our application. So the entire coding part was done. Then we will run our application. Run as a Spring Boot app. So here the application was started. So this Tomcat started on a port 8080, 8082. Go to the Postman. So here, so if you observe in our Spring Boot application, so here in a Pojo class, so whatever the client sent by the request, we are writing here. So ID, user ID, payment method, whatever the fields here we are using, the same fields we are passing here. User ID, payment method, provider ID, payment type ID, transaction status, amount, currency, merchant transaction reference, and in a controller class, if you observe payment controller, so this is the base URL /v1 /payments, and we are using the post request. So it is a post mapping post request http learn slash host colon 8082 /v1 /payments. So the request body, then send the request. So here we will change the transaction reference. Then send. So now the ID is 25 and transaction status is created. Then check whether it is stored into the database. So MySQL workbench. Now again we will make one more request as a transaction reference. I have changed. Then hit the request. Now the in MySQL database, it will stored as a ID 26 and transaction status ID is created. Then go to the MySQL workbench. So here if you update, and this is transaction table. So here with the ID 26, the transaction status and the log. So here in a transaction the ID was generated. So in our Spring Boot application, so here the payment process is started. the transaction object after conversion to a transaction DTO, the object is converted into a transaction DTO, transaction object to transaction DTO. Then the status enum is created, the creating the status handler for a status created, and the we are getting the bin from the application context, and then the in a create a status handler process the statuses. See, in a name the parameter JDBC template it uses, and by using the transaction MPL, it will create the transaction queue and convert into a NTO in a transaction. Inserted the, see, by using this inserted the value in a DB, count inserted row count ID as a 25. Again I have two times I have hit the in a postman. Again it will created ID as a 26. See here, it will created the ID as a 26 as we see just now. So here the in a response entity that we are getting the response 201 created. See if you observe 201 created. Create transaction ID 26 and the transaction status was created. So this is the overall whatever we are coded and whatever we are written logs we are getting end to end in our console. So the application is successfully running. So this is the overall discussion about this application. Payment processing service. Here we are successfully inserted the whatever the request we are receiving from the client.